Hey, Prop Stat students. Mr. Mitchell here. We're going to take a look at some more z-scores and area under the curve and working backwards today. Go ahead and pull up your notes. We're going to take a look at this PowerPoint. So area under the normal curve, we've been talking about that. Here's your z-score formula. So let me share my screen with you. There we go. So here's the z-score formula. Z equals x minus mu over sigma. Okay, we've been working with that for a couple weeks now, and we're going to continue to do that. We're going to use our formula. We're going to use our table to find probabilities. So let's take a look at a question. So the amount of time it takes for a pizza delivery is approximately normally distributed with a mean of 25 minutes and a standard deviation of 2. If you order a pizza, find the probability the delivery time will be between 25 and 27 minutes, less than 30 minutes, less than 22.7 minutes. Okay, so these are the types of questions that we've encountered and we're going to take a look at right now. Okay, so how do we worry about dealing with this? How do we work on? So we have to find our z-score first. We don't have a standardized score right now. We have raw scores. So these are X values, okay? And we have a standard deviation sigma here, and we have a mean of 25 here. So we got to find our z-score. So let's work on letter B first, because letter A is a little more difficult than B or C. So we're going to do B first, then we'll do C, and then we'll kind of go from there. So for letter B, trying to find the z-score. So it's 30 minus our mean, which is 25. Okay, so the raw score is 30, the mean is 25. And then we're going to divide by our standard deviation of 2. So I got 5 divided by 2 is 2.5. Now that's our z-score. That's our standardized score. That's how many standard deviations we are away from the mean. That is not our probability. That's not our percentile or area under the curve or anything like that. So we do need to go to our table. Let me stop share for a minute and see if I can find the table. Sorry about that. There we go. So I had to find my table to do this. Somehow I must have closed out my table. So here we go. Here's the standard normal table. So we have our z-scores here and our probabilities are in here. So we found a z-score of 2.5. So these are all the negatives. So I need to scroll to the positive. So 2.5 exactly is right here, 2.50. So that's 0.9938. 0.9938. So when I look that number up, my probability is 0.9938. And so before I finalize that as my answer, what am I looking for? I'm looking for less than. So if I draw a picture, that's to the left. So that is my final answer. Remember that our table gives us everything to the left. So that's what we wanted. So we're done. All right, let's take a look at letter C. So we want less than 22.7. So that's my X value minus my mean over my standard deviation. Okay. So what's 22.7 minus 25? What's that going to be? Negative 2.3. And then we divide by 2. What's that? Negative 1, negative 1 point something. Negative 1.15. Okay. Just check. Yep. So that's what we got. So now this is my z-score. Okay. So I need to find my probability. So I got to go back to the table. And I'm looking for negative 1.15. So I got to go to the other page. So negative 1.1, and I got to scroll over to 5. So this is 1, 2, 3, 0, 1, 2, 3, 4, 5. So 0.1251. 0.1251. And again, we're looking less than, so that is my final answer. Okay. Now I need to find the probability that I'm between 25 minutes and 27 minutes. So I really need to do two different questions here. I need to find the 25 number. So 0 over 2 is 0. And then I got to look that number up. Well, if you know the z-score is 0, it is going to be 0.5. But just to prove that, if you go to the table, here's 0.00 is 0.5. Okay, so that is a probability of 0.5. Okay, and now I just need to do the z-score for the 27. So I got 27 minus 25 over 2. So that's 2 over 2, which is 1. So now I need to look up the 1. So again, I go back to my table and I find just 1.00, so 0.8413. That gives me 0.8413. And now I just need to subtract these two. You always do the bigger number minus the smaller. When you're dealing with probability, it has to be positive. You can't have a negative probability. So that's going to be 0.3413. If you take this number minus this number, you get that. Okay, so that's calculating our z-scores and then our standardized values and then looking up their probabilities with that. Okay, so we've been working on that for a little while. Now we're going to get into just working backwards is really all that it is. Okay, sometimes we need to find an X, a raw score, or a standardized value that corresponds to a given area under the normal curve. Remember, area, probability, percentiles, they all really mean the same thing. In the table, we are looking up an area and finding the corresponding z value. Okay, so here's really what we're doing. We're taking the last problem. We're going to be given the probabilities, and we have to find the pizza delivery times. So that's different than what we just did. Okay, think about what we just did here in this question. We had the delivery times and we were finding the probabilities. Now we're going to have the probabilities and we need to find the delivery times, if you want to think of it that way. Okay. So looking at our picture, so when we do a left tail, we're going to look up the probability. We're going to find the probability that we want. And then we're going to look up the z-score. Okay. The other case is a right tail case. So if we have the right probability, we're going to do 1 minus that, and then we're going to look that number up. Okay. And then if we have a center case, we're going to do 1 minus the area that we have, and then we're going to divide that by 2. And that'll correspond to the 2 z-scores. We're going to get 2 z-score values whenever we have an area in between. So we're going to take a look at, we're going to practice a couple of those here. So here's an example. The area, all right, let's say we're finding this area. So I'm giving you the answer on this first one because we've done it. We haven't done it yet. This first time you're doing it. So pretend you don't have this. Okay, so I'm going to just kind of pretend that's not there. Okay, you don't know this. It's just pretend it's missing. So you're going to be asked, okay, you know the probability to the left or less than is 0.0051. So you're given the probability and you have to find the standardized score that goes with that. So you need to come inside the table. Okay, normally we found our z values and then we found these numbers, these probabilities. Now you need to, you're given the probability, you got to find it first, and then instead of scrolling like into the table, you're going to find that number and then scroll out of the table. So we find this 0.0051 or the closest thing we can to it. Sometimes our number may not be exactly on the table. We're going to find the number that's closest to it. So in this case, though, that number is right here. It's 0.0051. And so we're going to scroll to the left and scroll up. So where does this go to the left and go to the top? That's negative 2.57. And then that's our answer. That's our standardized value of where that probability happens. Okay, so it really is working backwards. Okay, so if you were good in the first place at finding probabilities, it's not really that big of a jump to now just go backwards. It's kind of like driving a car. If you could drive forward, you could drive backward. Maybe not as fast, maybe not as accurately, but it's still the same thing. To drive forward, you really have to be able to drive in reverse too, right? You go take your driver's test, you got to demonstrate you can do both. So it's the same concept here. So again, this one was done for us. Now we're going to take a look at this. So find the indicated z-score. All right, so first, they're probably going to say you want to be in the upper 1%. Okay, the upper 1%. So really what we need to think of is what's the lower percent. If you're in the upper 1%, what's the lower percent? 99. So this number may not have been given to us, or maybe it is. Okay, this number, they have to give you one of these two. Chances are a lot of times they give you upper numbers because you want to know what that upper echelon of something is. But to do our problem to find standardized values, you're going to have to do 1 minus that. So if I'm doing this problem, I'm really going to do 1 minus 0.01, and that's going to give me that number. Okay, so 0.9900. Okay, so really what we're going to do, we're going to find the number closest to it. Okay, so we got to go back to our table. And there's 2 pages. So if we start looking inside the table here, we're looking for 0.9900 or something close to that. So we start here and we look at all these numbers inside the table here. And here's a 0.4641. Well, that's not really that close. So maybe we need to go to the second page. So we need to find 0.99. Well, here, look down here. Here's a 0.98. Here's a point. Oh, here, see, here's a 0.99. Here's some. So really what we're looking at, looks like these two numbers are the closest thing that we can get to it, right? Here's a 0.9898. That's pretty close, right? 98%. It's 98% 0.98. So it's almost 99. And then this is 0.9901. So that's almost 0.99. It's pretty close. So it's somewhere in between here. So which one do you think is closer? I think it's this one, right? It's only one, it's 4 decimal places, just one number different. Okay, so what we need to do now is scroll to the left. So that's 2.3, and then get the second decimal up here. So our answer is 2.33. That's our z value, our z-score. Okay, so for this one, our z-score value is 2.33. And it's positive because it happened over here on the right. All right, remember our mean is in the middle. Our z in the middle would be 0. Okay, if you are exactly average, you have a standardized value of 0. Okay, so we need to know how to find the standardized score, because then maybe we might find a raw score then later. Okay, that's like the next step in the process. You find a raw score. We'll practice that here in a few minutes too. Okay, so now we need to find our standardized value with a probability of 0.7814 in the middle. Okay, so going back to our rule, here's the rule for the center. So you're going to take 1 minus the area, and then you're going to divide it by 2. Really what you're doing, you're trying to find the area in the tails. Okay, so let's take a look at this. So I have an area of sorry about that. I have an area of 0.7814. So we have to do 1 minus that. Okay, so when we do that, what do we get? Is that like 0.2186? I think I did my math right. Yeah. Okay, so we have this is the area of both tails put together. But I don't want both tails. I really what I'm looking for, if I can find this number, these two numbers are going to be the same, just one's positive, one's negative. Okay, that's really what I'm looking for. So I need to take this 0.2186 and I'm going to need to divide that by 2. Okay. So what is 0.2186 divided by 2? So when I do that, I get 0.1093. Okay. Take this divided by 2. So you get this probability. Well, now I need to look up that in my table. So 0.1093. So I come to my table. So I need to find, again, I'm looking in the table to find 0.1093. So this, it's not on the second page, it's on the first page. So I need to find 0.1. So look, notice how all these numbers are really, really small. 0.1 is the first decimal place. So I go down here, it looks like 0.1 is right about in here somewhere, right? Looks like it's in between these two. Okay. Oh, no, I'm sorry. I was looking for 0.1093, wasn't I? Let me just double check. I went back to thinking I was looking at for 0.1 only. So I'm looking for 0.1093. Okay, got it. So always double check. So 0.1093 happens to be right on my table. That's nice because I don't have to make a decision. Do I go up or down with the number? If it's on the table, you just know what to select. So here's my number exactly. So scroll to the left, you get negative 1.2. And if you scroll up, you get 0.03. So our Z value is negative 1.23. So our Z value here is negative 1.23. And then the other one is going to be the same thing. It's positive 1.23. So you have a negative and a positive. Anytime you have a symmetrical area in the middle, the Z values are the same number, except for one's positive, one's negative. The negative one's on the left, the positive one's on the right. Okay. So now we're going to take a look at this application question. So the verbal SAT test has a mean score of 500 and a standard deviation of 100. Scores are normally distributed. Okay, that means bell curves, Z-scores, all that stuff. A major university determines that it will only accept students whose verbal SATs are in the top 4%. This does happen. This is how some schools, they don't just have a specific number. They have a sliding scale from year to year. They might decide they only take students in the top 3%, 10%, whatever it may be. What is the minimum score that a student must earn to be accepted into this school? Okay. So I put it on a smart notebook file so that I could possibly write on it. So what we're looking for, we need to find our Z value. And then we need to find our X. X is the raw score. So we need to find our Z value from the table first. So top 4%. So sometimes drawing a picture is very helpful. So the top 4% is over here. Well, remember, I can't do the top percent. I need to do this number in my table. So if this is 4%, this has to be 96%, right? What they're saying is they're going to overlook 96% of the people, and they only want the top 4% is what this university is doing. So we're going to look in the table at 96%. So if I look at my first page where the negative Z-scores are, it doesn't go up that far because it's on the left side of the mean. So I need to find 0.96 or the closest thing to that. Okay, need to find the number that is closest to that. So 96, here's 95, there's 96. So it's somewhere in between there. So it's definitely, if I scroll out, it's definitely 1.7. Is it 1.75 or 1.76? I would lean towards it being 1.75, right? Because that's only, it's 0.9599. It's only one number on the fourth decimal place off, whereas this is 8 numbers off. Okay, it's still not a big number off, but if you have to choose between these two, you want to choose this. So that's 1.75. Okay, so when I come back here, my Z value from looking it up in the table is 1.75. Okay, that's my standardized value that I need to have. But that doesn't tell me what score I need to get on the test. That just tells me if you want the top 4%, now I guess you could memorize this for every problem you ever needed to do top 4%. I don't know why you would do that. But anytime you do the top 4%, the Z score value is going to be 1.75. That's never going to change. What's going to change is the context of the question. So I don't know my X value. My mean is 500. And then my standard deviation is 100. Okay. Or the other way, you were given a raw score formula before, X equals Z times sigma plus mu. Okay. If you remember that formula, you can just write it here, or you could just solve it using algebra. But what it's going to end up being is 1.75 times 100 plus 500. All right. And so when you take 100 times 1.75, that's 175 plus 500. So our score, you need to get a 675 on the verbal to get into this university, this college. Is it a college or a university? It's a university. Difference between a college and a university is the number of degrees they offer. So if a college decides to offer more programs, then they can become a university. It's not the number of students that attend. Some people think that that's what it is. Okay. So this is the purpose of finding. So I need to be in the top blank percent of something. Okay. I need to find my standardized score first, then I can find my raw score. Okay. So, and sometimes that top percent, the Z-score doesn't change from year to year, but that raw score could change because the average score can change from year to year, and so can the standard deviation. So they may always say, as a university, we want the top 10% of people or the top 5% of people, but then their score that they will accept might change from one year to the next because the mean and standard deviation are not the same every year. Okay. So that's everything in a nutshell. Again, it's the same thing we've been doing, except for we're just driving in reverse. I'm not saying that it's easy, but it's not a completely new concept. It's just backing up instead of going forward. So let me know if you have any questions.